You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged here, episode 47. I am Dan Klamert, your host, and happy holidays, everyone. I hope everyone had a great Thanksgiving. That was right, our last episode was right before Thanksgiving. And on today's episode, here, number 47, which will be the last episode here of 2024, I am very excited. We have a great action-packed agenda here, a little bit longer today. We're going to be talking about Cisco's AI-driven Wi-Fi 7 technology and some of our new products that we just announced. So we'll be announcing those here today. And we have a special guest here today. I'd like to welcome back to the show, Anand Gurumurthy. Hey, Anand, how are you doing? Welcome.
I'm doing great, sir. I'm super excited today to talk about Wi-Fi 7.
Yeah,
Um,
thank you. Thank you very much for joining us. And so, Anand, you're the senior leader of the technical marketing team at Cisco, right? And you live in out in San Jose?
yes, I'm living here in San Jose. I'm a technical marketing engineer focused on the Wi-Fi products and solutions, and I've been with Cisco for a very long time now. So I don't want to reveal the number of years that I work here, so that's going to reveal my age. So yes, I'm not a new face to Cisco. Yeah.
Yeah. Thank you very much for joining us once again here. I know you have been with us before. So before we get started real quick and we turn it over to Anand to get into some of the great technology here in Wi-Fi 7, I just want to remind everyone we do take questions live here on Unplugged via Slido. So you'll see those QR codes. You can quickly, easily join via those QR codes. If you are watching via YouTube, the link is below in the notes. You can click on that link and join there as well and submit any questions. We do have people that are monitoring and answering those questions. We do also, I will be monitoring those and interjecting questions as we have time here as well. So get those questions in. And then I mentioned YouTube. As a reminder, we do record this and we are streaming live on YouTube right now. The channel, youtube.com/@getunplugged. I'd encourage you to subscribe if you haven't yet. And then click on notifications. You'll be notified when we do go live with more great content like this. We are back January 8th. We'll be talking about a little bit more into beyond Wi-Fi 7. We'll be talking a little bit about the Meraki Campus Gateway as well. So go out there, subscribe, click on notifications. You'll be notified when we do go live with more great content like today's episode. So I think that's it for the reminders. So let's get unplugged here. Anand, I know you got some exciting stuff to talk about, so I'll turn it over to you for the agenda.
Okay, thank you, Dan. Thank you, Unplugged team. Thank you for inviting me to speak about the most exciting thing that's happening in the Wi-Fi world today. That's Wi-Fi 7. Of course, it's gotten lots of traction, lots of curiosity and interest in the Wi-Fi community. Wherever I go and whoever I talk to nowadays, and when the subject comes to Wi-Fi, the discussion is most likely on Wi-Fi 7. I'm indeed very excited to join today's Unplugged episode and share my knowledge on Wi-Fi 7 with the audience here. I also want to take a moment to welcome and thank the viewers who have tuned into today's episode to hear about Wi-Fi 7. As Dan mentioned, this is the last episode for this year in the Unplugged series, a great way to definitely wrap up 2024 with a discussion on Wi-Fi 7, and the timing can't be better. On the agenda today, I want to mainly cover three topics. First is to get to know about Wi-Fi 7 as a standard. We'll start with the problem statement on why Wi-Fi 7 at all to begin with, and then we will get into the what aspects of it, do a technical dive into the features, but not necessarily a deep dive at the bits and the bytes level. We'll look into each of the features and the benefit that it brings in. Secondly, I'll introduce the Cisco's Wi-Fi 7 access point portfolio. We recently launched our first set of access points and we have received great reviews. I'll go over the product details and the features. Thirdly, we'll wrap up the session with a discussion on deployment and migration considerations the end users need to be aware of if they want to adopt Wi-Fi 7 in the network. So with that, let's begin the session. So this seems to be my favorite slide that I can't seem to get rid of it. This gives a nice summary of the different Wi-Fi standards and the timeline of the Wi-Fi evolution. This is the 25th anniversary of Wi-Fi. Yes, Wi-Fi Alliance was formed in the year 1999, and the first generation of formal Wi-Fi came into existence based on the 802.11b amendment with a mere speed of just 11 Mbps per second in the 2.4 gigahertz spectrum, which has just about 3 non-overlapping 20 megahertz channels. The 5 gigahertz spectrum got added a few years later. Wi-Fi has had a stupendous growth since then, with speeds increasing multifold, with the data rates almost reaching about 30 gigs per second with the most recent 7th generation of Wi-Fi, that is Wi-Fi 7. It's just not the speed alone, it's the capacity as well. There's been an exponential growth in Wi-Fi devices, and I'm sure each one of us have multiple Wi-Fi gadgets with us. When I look around, I can easily count like 4 to 5 devices just sitting next to me. So the applications have come a long way as well, and Wi-Fi has become the default medium of access, where it has to take care of the collaborative applications like the video conferencing, which are bandwidth hungry. And at the same time, they need a consistent latency and jitter. The AR and the VR applications are finding its place in enterprise deployment, and their applications are very stringent on SLA. And we are looking at an SLA requirement of 10 milliseconds or even lesser. Industrial IoT applications with automated guided vehicles and mobile robots are becoming very common nowadays, and they need a deterministic network and are stringent on SLA as well. So now the question is, can I run these applications in the Wi-Fi infrastructure what we have today with the 2.4 and the 5 gigahertz spectrum? So the answer to this question, in my opinion, is maybe. And the reason that I'm being very skeptical is, number one, channels are congested, especially the 2.4 gigahertz spectrum has literally become unusable with all those interference and the channel utilization being so high. And some of the customers with whom I work with, they've completely shut off the 2.4 gigahertz band, and they've turned on only the 5 gigahertz band to give their best user experience to its end users. So that kind of shifts the load on the 5 gigahertz band. And if you look at the 5 gigahertz band, there are not that many channels if you exclude those radar channels. So the ground reality is the spectrum is stretched to the limits. And the good thing is the regulators and the governing bodies realized this and added the 6 gigahertz spectrum space, which is mostly pristine for unlicensed use of Wi-Fi. This happened about 3 years back, what we termed this as Wi-Fi 6E, and which we started seeing the benefits. So 6 gigahertz spectrum lays the foundation for the future growth of Wi-Fi. If you look at, we have 1200 megahertz of spectrum or 500 megahertz of spectrum in countries like Europe and parts of Asia. Even those countries, they've started thinking about opening up the entire 1200 megahertz of spectrum. This is a lot of spectrum. There's going to be a huge impact to the Wi-Fi market. The new Wi-Fi standards starting from Wi-Fi 6E, Wi-Fi 7 is all built on this foundation. In summary, the 6 gigahertz spectrum is absolutely needed for the future Wi-Fi standards like Wi-Fi 7 and 8 to unlock its full potential. With that conclusion on the 6 gigahertz spectrum, let's now explore what Wi-Fi 7 is all about. So what's Wi-Fi 7? Wi-Fi 7 is based on this IEEE 802.11b amendment, termed as extremely high throughput. Wi-Fi Alliance, which is an independent body, picks these IEEE specs, adds the security component, adds the QoS component, and comes up with the feature list for that particular generation of Wi-Fi. Wi-Fi Alliance has come up with 2 releases for Wi-Fi 7. The release 1 specs were finalized early this year, around January of this year. And Wi-Fi certification for release 1 is in full swing, it's in progress. And release 2 is expected December of 2025, 1 year from now. R2 will have just only minor updates, and it's just going to be a software update, and it's not going to be a hardware spin. IEEE 802.11b amendment is ratified. It's in the final phase. It's just pending publication, and the final publication is expected sometime in February or March of 2025. So for any Wi-Fi generation to gain momentum in adoption, the specs have to be complete, the infrastructure has to be ready, and there should be good support from the client ecosystem. So the Wi-Fi client availability is definitely picking up momentum. We have a rich set of clients now. We have still some more distance to go, but we are getting better every month. So Cisco has been very closely involved in the development of IEEE amendment of 802.11be, and also involved in the WFA task force, coming up with the feature list. Cisco also advocates thorough client interrupt testing. We work with several client vendors and do lots of interrupt testing. Of course, the client vendors also do interrupt testing with our access points. We exchange notes, have regular cadence, resolve many issues upfront. The reason to do this, we want to get the best code to the customers. And imagine if there was no testing that was done, or minimal interrupt testing that was done, the end user experience is going to be a nightmare. So what are the use cases that Wi-Fi 7 is trying to solve? Mainly centered around these two parameters, like bandwidth and the latency. It wants to take Wi-Fi 7 is trying to address those bandwidth hungry applications, like those video conferencing applications, and latency sensitive applications like the AR, VR, XR, industrial IoT, immersive gaming, and immersive learning. Pretty much along the lines of Wi-Fi 6E, but it's just trying to improve the numbers even better. So I mentioned that Wi-Fi 7 is termed as extremely high throughput. When you look back, the fourth generation of Wi-Fi based on 11n was termed as high throughput. And fast forward, the fifth generation of Wi-Fi, 11AC, was termed as very high throughput. And with 11ax, with Wi-Fi 6, the attention shifted towards spectral efficiency, and it was the features like the YFDMA and BSS coloring, they all brought about the efficiency aspects of it. And fast forward to Wi-Fi 7, with the 11B, it's again termed as extremely high throughput. It seems to look like as if it's back to the speeds and the feeds. But if you take a closer look at the features, it's just not the speeds and the feeds alone. Well, there are features like 320 megahertz and 6 gigahertz, 4K QAM, MLO, they all contribute to the improvement in data rates and improvement in throughput. But there are features like preamble puncturing, multi-RU, compressed block hack, they all contribute to the efficiency aspects of it. Wi-Fi 7 also mandates the WPA3 and enhanced open as the as a minimal and mandatory for the Wi-Fi 7 features. There are some more slight enhancements when compared to Wi-Fi 6E. There are some new AKMs and ciphers that is added for the WPA3 personal and enhanced open. There are also some QoS enhancements like triggered uplink access optimization. There's just nothing but our fast lane plus feature, but that's getting standardized now. So now let's get into each of these features. The very first one is 320 megahertz channel width in the 6 gigahertz spectrum. Of course, whenever you double the channel width, it's going to help improve the throughput. So if you look at the 6 gigahertz spectrum, you have 1200 megahertz of spectrum in US. So that can get you about 320 megahertz channels when the AP is operating in low power indoor mode. But when the AP is operating in the standard power mode, you just get only one 320 megahertz channel. In Canada, maybe you may end up getting two 320 megahertz channels because of the Uni6 addition there. But for those countries with 500 megahertz of spectrum, you get only one 320 megahertz channel. So this is one of those features that looks good on paper, but it has practical implications for the enterprise deployment. Maybe in US, certain parts of the floor, you can configure the access points to be with the 320 megahertz channel width, but this is not a feature that you can widely deploy in enterprise deployment. The next one is the 4K QAM. The modulation is increased from 1K QAM in 11ax or Wi-Fi 6 to 4K QAM in 11b. QAM or quadrature amplitude modulation is a kind of highly developed modulation scheme used in wireless transmissions to transmit over radio frequencies. Higher modulation means higher density of data, that is packed more data in a single transmission. And of course, this is going to help achieve higher data rates. Wi-Fi 7 introduces two data rates, MCS 12 and 13. But if the radios have to maintain such high modulation levels, the requirement is SNR has to be very high, ridiculously high. We are looking at about SNR of close to 42 or 43 dB when compared to like the 31 dB with the 1K QAM and 25 dB with the 256 QAM with the 11 AC. So is it possible to achieve such high SNR? The environment has to be really pristine, like no noise level, no noise floor, and wireless clients have to be very close to the access point, maybe about 7 to 8 feet distance to really get such modulation levels. This is not going to be a widespread benefit in a given cell, but definitely some parts of the cell can really benefit from this. And this is the only way to, by increasing the modulation levels, is the only way to increase the kind of data rates. Moving on to the next feature, the most promising, interesting, and the coolest feature in Wi-Fi 7 is the MLO or multi-link operation. If you look at the way the clients communicate with the access point today, they establish an association with the access point in one of the bands. And after the association is complete, they start exchanging the data. But with MLO, the clients and the access points can establish association on multiple bands, and they can exchange data on multiple bands simultaneously. So think of this as the link aggregation or the Ether channel feature that we have in the wired world for many years now. This is not exactly link aggregation, but this is the closest feature comparison that I can think of. Now that we have multiple links to communicate and exchange data, obviously it brings in some benefits. Let's go through some of the benefits. The first benefit is I can think of is a throughput. So the clients and APs now have more than one link to exchange data. Obviously, it's going to help increase the throughput. Applications like the video conferencing, can really benefit from this. The second benefit is the lower latency. The client and the AP can dynamically steer the flows towards the link that can get a better SLA based on the channel conditions. Let's say you start off with the 6 gigahertz link, and the client and the AP determine that the 5 gigahertz seem to can provide a better SLA. It's going to shift the flow towards the 5 gigahertz and keep moving dynamically. So of course, this is going to help applications like the AR and the VR and industrial applications, and also help in the kind of to get a very deterministic network. The third one is the redundancy, where the clients and the APs send the same data on multiple links. If for some reason, if one of the packets in one of the links gets corrupted, then the duplicate data from the other link can be used for processing. So this helps to, of course, improve the reliability. Think of an application like a remote surgery that's being performed over a Wi-Fi infrastructure, where you cannot afford to have any data drops at all, because that's such a critical operation that's being performed there. The devices that,
Oh, sorry. I don't know if you want to finish that thought.
Yep, please go ahead. So,
Yeah, so we have a few questions coming in here, and I'm super excited about MLO here. As you started by talking a lot about the throughput benefits, which are great, but this definitely focuses more on the reliability side, which is excellent as well. A couple of these questions, I guess before I get into the MLO questions, there was one question, I believe you said it, but I just want to make sure we get the right answer to the viewer. How far away from the AP, and again, this isn't a perfect world with no noise and whatever, a clean environment, from the AP would 4K QAM work? And I think you said it was very close, and it was pretty close to the AP.
It's very close. Like we looking at about 7 or 8 feet distance.
Yeah.
That's the typical environment. But in a controlled environment, you can could be slightly far. But from our practical testing, this is the closest that I can get my clients and the access point lock at that modulation level.
Got you. Thank you. And then back on the MLO topic here. So one of the questions is, does MLO authentication on multiple links increase 802.1x load?
No, the way it works is it doesn't increase any load. There's something called a primary link. All this happens on the primary link. It's not like it's going to authenticate on all the other links.
Okay.
But
it's more of a redundancy than it is like separate authentication across each channel or across each band, I should say.
Yeah. So hold on to that thought.
Okay.
It's I want to answer in a very short way. It doesn't increase the authentication load in any way. So
that's fair. I think you had a demo too. So stay tuned for the demo here on this later. But yeah.
Any other questions?
I think, let's see here. I think we're good at this point. Thanks.
So because of this multi-link operation, the MAC layer is split into two, upper logical MAC layer, and that's it, and a lower MAC layer, it's a physical MAC layer. The upper MAC layer, it's a logic layer. It performs the link agnostic operations like the authentication, association, encryption, decryption of the unicast frames, and so on. And the lower layer MAC, which is a physical MAC layer, performs the link-specific operations like those management frames, or beacon frames, probe response frames, control frames like RTS, CTS, acknowledgement frames, and also the power states and the modes. The reason for me to flag this slide here is the user needs to be aware of that's a break in the MAC layer. At some point of time, probably they may debug. They may look into the log files or the Wireshark captures, so they need to know what MAC address to actually look for. Or maybe the users may be having some policy enforcements in the radius servers. They have to use the upper MAC layer for all the policy enforcement there. So moving on, there are many modes of MLO. Because the clients have different hardware capabilities, it's more of a limitation on the client side rather than the limitation on the access point side. At a high level, we break this into a single radio and a multi-radio. Single radio is where the clients have just one single radio, but they perform a multi-link operation. And multi-radio is where the clients have multiple radios, and they use each radio to connect to different bands and perform the multi-link operation. So MLSR, or multi-link single radio, is the most simplest form of the MLO. So the way it works is the client just has a single radio, and but it forms kind of an association with multiple links. But any given point of time, it just uses only one link to exchange data. If for some reason that band or the link becomes congested, then it just switches over to the other link. It's not a reassociation. It's not a roaming. It's just a switchover. And, it saves a lot of time during typically the roaming takes over. The second one is the EMLSR. It's an enhanced multi-link single radio. It's the MLSR, plus the client has the capability to listen to two links simultaneously and use the link wherever it gets the transmit opportunity. In the multi-radio, there are again two methods, MLMR, or multi-link, multi-radio simultaneous transmit and receive, or call as MLMR STR, wherein the client has multiple radio and each radio operates independently to transmit or receive the data. MLMR, non-simultaneous transmitter and receive, or MLMR NSTR, is like where the radios have to coordinate to send or receive the traffic. So this is a kind of a slightly complicated mechanism. This is not included in the Wi-Fi certification, but the 11B standards does include MLMR NSTR. So the two most popular MLO methods out there is the EMLSR and in the single radio, and MLMR STR for the multi-radio. An example devices, the EMLSR, all the Intel chipsets, they use the EMLSR. And an example for MLMR is the Qualcomm chipsets. So if you get a Windows laptop with an Intel chipset, it's going to do the MLSR method. And if you get a Qualcomm Windows laptop with a Qualcomm chipset, it's going to do an MLMR SDR. So the Wi-Fi certification, though, it expects that the access points need to support MLSR, EMLSR, and MLMR. But on the client side, it has to support MLSR. In addition, it has to support either EMLSR or MLMR. There are, of course, pros and cons to each of these MLO methods. EMLSR with a single radio, of course, the cost is going to be lower. It's going to be a bit easy on the battery, but the throughput is not going to be the best. But with the MLMR, which has multiple radios, you're going to get the best throughput, but it's not going to be that easy on the battery. And of course, the cost is also going to be high. So moving on, here is an illustration of how EMLSR works. This is after the association is formed. The wireless client, here is an example of a wireless client with a 2x2 radio chain with two spatial streams. I've taken the 5 gigahertz and the 6 gigahertz as an example here. So the client uses one of the radio chain to listen to the 5 gigahertz band, other radio chain to listen to the 6 gigahertz band. Access point wants to send some data out to the wireless client. So to begin with, the medium is busy. And the access point determines there is a transmit opportunity in the 5 gigahertz link. So it's going to send an RTS frame. It's a MU RTS frame, just nothing but an RTS frame with the multi-user info. And the wireless client is going to send a CTS frame back. And at this point in time, the wireless client is going to shift both its radio chain to listen to the 5 gigahertz band. And while the access point sends the data down and the client sends an acknowledgement back. And again, at this point, the client will go back to the listening mode, one radio chain in each of the bands. The next time the transmit opportunity could be on the 6 gigahertz band, the same set of sequence happens. And the MLMR STR operation, the wireless client has two radios. And, to begin with, the medium is busy. And after that, the client, the data can independently transmit and receive data. And of course, you're going to get the maximum throughput and performance because there are two radios that's operating on two independent channels. Few notes on multi-link operation. When I say MLO today in Wi-Fi 7, it's the clients connecting to multiple bands to the same AP and not to multiple APs. So that's something coming in Wi-Fi 8. Secondly, what we have seen is MLO functionality today is going to be most likely on two bands, even though the AP is what we have today. It's all tri-band AP. But I've seen some clients do perform 3 bands. The one of the clients that what I've seen recently is the iPhone 16. A couple of times I was able to get on MLO functioning on the 3 bands. Thirdly, what we also observed is if SSID is broadcasted on all the radios, the clients seem to prefer doing MLO on the 5 and the 6 gigahertz MLO links mostly. And one being the associated link, the other one could be the secondary link. It doesn't matter. It could be the 5 gigahertz could be the primary link and 6 gigahertz could be the secondary link, or purely based on the channel conditions. And we talked about MLMR STR, which is multi-radio, and the band isolation on clients between the 5 gigahertz and 6 gigahertz spectrum, because the spectrum is so close. Some clients could do only 2.4 plus 5 or a 2.4 and a 6. But I've also seen many clients doing a 5 and 6 though, but don't get panic if you see some clients doing always doing a 2.4 and a 5 gigahertz or a 2.4 and a 6 gigahertz. It's purely the client's limitation. Of course, there are lots of details here in MLO. The devil is in the details, single radio versus multi-radio, STR, EMLSR. And I've gone through many of the client specs, and most of them don't seem to list the exact MLO method that they're operating on. But we are trying to bring the visibility on the controller side, the Catalyst 9800 controller, as well as on the Meraki dashboard on the exact MLO method that the client is performing. We performed several tests on MLO to see the obvious improvement that we get, both in terms of throughput tests and some latency tests. So the Wi-Fi 6 client is operating on a 5 gigahertz with 40 megahertz channel width. And the Wi-Fi 7 client is doing an MLO with a 5 and a 6 gigahertz with a 40 megahertz channel width. As you can see in the chart, the throughput is almost twice the 2x of what we get in when compared to Wi-Fi 6 client. Here's another example of downlink throughput test, but the difference here is the Wi-Fi 7 client was operating on 2.4 gigahertz with a 20 megahertz channel width and a 5 gigahertz with a 40 megahertz channel width when compared to the Wi-Fi 6 client, which was operating on the 5 gigahertz with a 40 megahertz channel width. So the gain here is like close to 50% because of the 2.4 gigahertz with a 20 megahertz channel width.
Hey, Anand, we did have a question on this, but I don't know that we have the answer yet because it was more future looking or forward looking. But I'm super excited about MLO. I think this is huge, not just from a throughput perspective, like you just outlined there, but also from a reliability perspective. The question was more along the lines of, and it's more of just something that's kind of fun to think about, is around how will roaming look come Wi-Fi 8, potentially with multiple APs. And I don't know that we have an answer to that at this point, but it's just the possibilities and the options, features that come here with MLO are super exciting.
Thank you. MLO is really a game changer.
Yeah.
And of course, there are a lot more capabilities that's being planned around MLO. So Wi-Fi 7 and Wi-Fi 8 is going to be really fun with this MLO feature.
Agreed.
So here is a demo that I want to walk you through. So the client implementations vary. Like the clients, when we say multi-link, multi-radio, the clients don't seem to turn on both the radios always. So let's first see the demo. Here's a Wi-Fi 7 AP that's sending some traffic to a Wi-Fi 7 client. It's a downlink traffic. And initially the traffic is very less, and it's just operating only in the 5 gigahertz band that you can see in the spectrum analyzer. After some time, we started pushing the traffic more, and you can see now the AP and the client started engaging both the bands, like the 5 gigahertz band as well as the 6 gigahertz band that you can see in the spectrum analyzer. So the point that I want to drive here is, even though when I say multi-link, operating on multi-radios, the clients up to certain threshold always seem to operate only in one band. And when it crosses the threshold, it seems to engage the other band. So the reason is it doesn't want to turn on both the radios and be very harsh on the battery. So, I mean, this is the actual behavior that what we are seeing in some of the multi-link, multi-radio STR clients, mainly to conserve the battery. We also performed latency tests. MLO brings in definitely latency improvements as well. So the latency tests are when compared to a single link operation client, like with the Wi-Fi 6 client. As you can see in the chart, like there are very clear latency improvements. We're always able to achieve like close to 10 milliseconds or less than 10 milliseconds of latency in the MLO. So, and this latency test was performed without any QoS or QoS enhancements that is present in Wi-Fi 7. It's just a plain vanilla best effort test when compared to a single link operation and a multi-link operation. So in summary, the key takeaway from this slide is there are latency improvements just with the MLO. Moving on to the next feature, an important feature when compared to Wi-Fi 7 is the preamble puncturing. Preamble puncturing is like the AP carves out a portion of a channel or punctures a portion of a channel when there is interference in one of those secondary channels. So the way Wi-Fi 6 was operating, let's say if you take an 80 megahertz channel width, and if one of those secondary channel was affected by an interference, then all the secondary channels gets wasted. So you'll lose about 60 megahertz of channel width. Come Wi-Fi 7, if one of those secondary channel is affected by interference, then only the 20 megahertz channel width alone is carved or punctured out, and the remaining 60 megahertz of channel width is used for data transmission. This preamble puncturing was introduced in actually 11AX Wi-Fi 6 for OFDMA transmissions. Wi-Fi 7 supports preamble puncturing for both YFDMA as well as non-YFDMA transmissions. It's mandatory in Wi-Fi 7, whereas it was optional in Wi-Fi 6, and pretty much nobody implemented in Wi-Fi 6. And of course, preamble.
Anand, oh,
Yeah.
sorry. I didn't mean to interrupt. Just a question here that came in. This is another great feature and will definitely make these wider channels much more efficient. The question is, what causes preamble puncturing? Is this clean air, noise reduction, or noise detection? How about severe co-channel interference from other Wi-Fi networks?
I would say any sorts of interference.
Sure.
Mainly like the clean air kind of interference, the radar events,
Sure.
the AFCs. But maybe when beginning with the code, what you get, you may see some obvious improvements with the clean air kind of persistent interference.
Sure.
And RRM is going to be definitely involved, and any radar events or AFC related events, like preamble puncturing plays a role there as well.
Okay, thanks.
Yep. And of course, preamble puncturing is allowed only with 80 megahertz of channel width or higher, because for 40 megahertz channel width doesn't make sense, because you have only one 20 megahertz of secondary channel. And preamble puncturing, of course, contributes to the spectrum efficiency aspects of it. It is a demo of preamble puncturing. We have a Wi-Fi 7 AP, again, sending traffic to a Wi-Fi 7 client, and we are using IX Chariot to send the traffic. So the Wi-Fi 7 AP is operating on channels 36, 40, 44, and 48 of the 5 gigahertz band. And the transmission is normal. Everything is great. And an interference gets introduced in channel number 40. So as you can see, the channel number 40 getting affected by interference, but the data transmission continues in other channels, that is the channel numbers 36, 44, and 48, and only the channel number 40 alone gets punctured. So
That's
here
really
is
cool.
the big difference when compared to the Wi-Fi 6 and kind of Wi-Fi 7 operation. You don't lose those secondary channels. If it had been Wi-Fi 6, you'll see only the channel number 36 alone transmitting the traffic. Wi-Fi 7 multiple resource unit, the next feature in Wi-Fi 7. It's an enhancement to YFDMA feature that was present in Wi-Fi 6. YFDMA, as you all know, is the most significant and important feature of Wi-Fi 6. It allows multiple clients to transmit or receive from an access point at the same time by sharing the available bandwidth. YFDMA helps in spectral efficiency, and of course, it improves transmission latency as well. The way it works is YFDMA groups the subcarriers in a channel width to smaller portions called resource units, and these resource units are in turn mapped to the different wireless clients. So think of these resource units as the packing boxes, and the transmission as the containers. And the Wi-Fi 6 had a restriction wherein only one RU can be transmitted to one wireless client in a single transmission, or in other words, one single packing box in one single container. So this resulted in lots of wastage of the spectrum. The big difference in Wi-Fi 7 is it removes this restriction of one RU per client and allows multiple resource units to be assigned to each wireless client. So this again kind of helps in the spectral efficiency. And of course, it's going to improve a lot in transmission latency as well. 16 spatial streams. The reason for me to mention this is it's actually not supported in Wi-Fi 7. But if you go do a Google search on any of those Wi-Fi 7 technical content, I'm pretty confident that about almost all or majority of those technical papers out there calls for support for 16 spatial streams in Wi-Fi 7. So this proposal was initially made to the IEEE.11be committee, but it was not carried forward and it was dropped. So Wi-Fi 7 is capped at 8 spatial streams max per radio. A given AP could have definitely more than 8 spatial streams, but a radio in an access point, the max it stays at 8 spatial streams. Almost all the public DOS refer to 16 spatial streams. That's something not supported in the Wi-Fi 7, the access points. Moving on to the next important topic when it comes to the Wi-Fi 7 is the security. Security and the Wi-Fi protocols kind of go hand in hand. And Wi-Fi 7 also calls for WPA3 as the minimal and mandatory that is needed for Wi-Fi 7 operations. Pretty much whatever we saw in Wi-Fi 60 days, all those conditions apply here. Only thing is there is some couple of new AKMs that's been added for WPA3 personnel in Wi-Fi 7, which is called the WPA3 SAE extension key, key or fast transition SAE extension key. And there are also enhanced ciphers for WPA3 personnel and OWE. And of course, PMF is mandatory and it's absolutely needed. Here's a comparison of Wi-Fi 6, Wi-Fi 6, and kind of Wi-Fi 7 on as to what are all the different AKMs and the ciphers that is needed. So you can look at for OWE, we have this new cipher GCMP 256, and of course, there's an optional one. And for WPA3 personnel, we have the new AKMs 24 and 25 called the SAE extension key or FT SAE extension key. And we also have this optional cipher of GCMP 256. Of course, improved cipher is going to give you a better encryption and speed, and an improved AKM is for the better security. So one of the questions, yep.
Oh, I'll let
Please
you
go
finish.
ahead.
Oh, okay. I'm just trying to interject a question here. So this is around WPA3, and they're referring to a previous Wi-Fi 7 presentation where they were told that SSIDs would need to support, WPA3, SAE, OWE, even if those SSIDs are not configured to be used by 6 gigahertz. Has this been corrected so legacy SSIDs can still function on a Wi-Fi 7 AP?
Wi-Fi 7 AP as such is backward compatible with the legacy security types like WP8 and so on. Sure. Let's say you have an SSID configured for a WPA2. It's going to be broadcasted on the 2.4 and the 5 gigahertz bands. It's not going to be broadcasted on the 6 gigahertz band. But the clients, even though if it's a Wi-Fi 7 capable client, it cannot get those Wi-Fi 7 features like those improved 11BE rates and the MLO operation. The client's capability is restricted to 11AX or earlier. Yeah. So that's a key thing. In short, in summary, the Wi-Fi 7 AP is capable of broadcasting a lower security, but the client's operation is restricted to 11AX, and those lower security SSIDs will not be broadcast on the 6 gigahertz. So if you really want the Wi-Fi 7 capability, like the 11B rates and the MLO functionality, the security has to be WPA3 with all those the AKMs that I mentioned just now.
Yeah, and that's part of the standard. That's not something that's specific to us here.
It's absolutely not specific to Cisco, and it's what the standards calls for.
Yep.
And that's the only way to force users to kind of improve their security in their networks. And it's all done for good, to make their networks more secure.
Definitely. Thanks, Anand.
Moving on to the next part of my agenda, on the Cisco wireless Wi-Fi 7 product portfolio. We recently had a very successful launch of our first set of Wi-Fi 7 access points. It's an unified product. By unified product, I mean this access point can operate in the 2 deployment modes that what we have at Cisco. The on-prem based Catalyst wireless stack and the cloud-based Meraki wireless stack. So, of course, we used to have 2 separate product lines. And of late, what we are seeing is more and more customers seem to be wanting to migrate from on-prem to cloud for ease of management and operational simplicity. So whenever they move, they have to completely rip and replace the hardware, including the brackets. Of course, this results in lots of overhead in terms of money, time, and effort. And realizing this, we went ahead with a common hardware that will kind of give the customers the flexibility and avoid all the overheads that I mentioned about. We started this journey with our Wi-Fi 6 access point. We arrived at a common hardware, but we still had a separate SKU, one for Meraki and like a bunch of 7 or 8 SKUs for under the Catalyst mode. Of course, we reduced the SKUs in the Wi-Fi 6E, but our long-term goal was always to have just one SKU per model that can work in either of the deployment modes right on day zero, purely based on the user's intent. So here we are with the unified product with our Wi-Fi 7 access point with a single SKU per model, what we call as the global use AP that you can connect to on-prem based on-prem based Catalyst wireless stack or Meraki dashboard right from day zero. And it's the same AP that you can operate anywhere in the world. Gone are those days where you got to buy the country-specific or the region-specific SKUs. So if you have an access point that is purchased in US, you can very well take them to Canada and you can operate them in Canada as well.
So this is huge. So if I just want to make sure everybody got this and heard this and I heard this right. So if I'm a customer looking for Wi-Fi 7 now, I don't need to worry about, am I going to cloud? Am I going on-prem? I'd buy a single SKU no matter where I am, no matter what deployment model or method I want, and I'm good to go.
Absolutely.
That's
and
awesome.
you can use them on day zero. And a few months down the line or a few years down the line, you change your mind. You want
we want to migrate to cloud. Eventually, we can do that then.
It's a very simple workflow through which you can migrate these access points from one mode to other mode.
That's great.
And of course, when we build our product, we not only build the best-in-class for Wi-Fi connectivity, but we build a truly multilingual access point that brings in exceptional value to the modern digital enterprise. So we continue to have many of those existing functionality like flexible radio assignment, third-party hosting for IoT applications, a dedicated IoT radio for the BLE use cases, dedicated scanning radio to detect interferers, rogues, and all those attacks, the dual Ethernet port on our high-end access points, and so on. In addition to that, with the Wi-Fi 7 access points, we have introduced an ultra-wideband radio, and also we have added an inbuilt GPS module as well. So the UWB radio, along with the IoT radio, the Wi-Fi, and GPS, helps in many location-based use cases like indoor navigation, asset tracking, AP auto-locate, and AFC, and so on. So the Wi-Fi 7 access points also have a built-in accelerometer that it comes very handy for post-deployment verification of how the AP is installed. So to begin with, we have introduced 3 access points on the high end across 2 product families. On the very high and that you see on your right-hand side is our CW9178, Cisco Wireless 9178i, that has support for 16 spatial streams across 4 radios, a 2.4 gigahertz radio with operating in a 4x4 radio chain with 4 spatial streams. And then we have dual 5 gigahertz radios, each operating in 4 radio chains. And we have a 6 gigahertz radio operating in a 4 radio chain. So, and it also has a dual 10 gigabits dual 10 gigabits Ethernet port. The next in line is, of course, our 9176 series. We have 2 product variations here. The I model is with an omnidirectional antenna. So the D1 model has an integrated directional antenna that will solve many of those indoor external antenna use cases, typically in retail, auditoriums, long hallways, and so on, where you want to focus the RF energy. So this is a predecessor to our 916061, which was a super hit in the Wi-Fi market. So of course, all the above access points are indoor access points with an integrated antenna. They work with the same bracket as before, and these brackets have been there for ages. There, like if my memory serves correct, it's been there for the past 17 years or so. And since the days of Lebanon days, so it's just a matter of slide out and slide in the new access points. These access points are, of course, already Wi-Fi 7 certified. And of course, you can visit the Wi-Fi org website and to get all the details about these access points. These access points have, of course, brand new design. And we continue to give importance to the aesthetic aspects of the access points to keep those interior designers very happy. The access points are designed by this, this company called Pininfarina, the famous designer who designs all those fancy cars like Ferrari. Of course, on the port side, we have an enlarged recess area that helps in the cabling experience, significantly. This is a port side view of the AP. On the 9178, we have like two 10 gig Ethernet ports, a console port, a USB port on the side, and an external GPS antenna port if one wants to plug in an external GPS module. The 9176, it's pretty much the same view, except that it just has only one 10 gig Ethernet port. We have paid attention to very small details. We now have a removable console cover, so the installers can now plug in the Ethernet cable correctly and confidently and without a doubt. We have a QR code, which on scanning takes you to the install guides. We have improved USB cover, an elegant GPS antenna cover, same reset behavior, reset button behavior for both the modes, all good stuff here.
Yeah, that's not a big thing, but it is a big thing. It's like one of those small details that how many times have we had someone, an installer, and I'm not throwing shade to any installers here, but we're all trying to move fast and you don't look, you plug it into the console port or something and you're wondering why those APs aren't connecting. So that's really nice.
Exactly. So the Wi-Fi 7 APs also have a lot more capability now with the addition of UWB radios, the GPS, the accelerometer, and so on. But we have maintained the dimensions and compared to the previous models. Here is a side-by-side comparison of Wi-Fi 7 APs with the 6E and Wi-Fi 6 access points. We have ensured and we're very particular that we maintain the dimensions and the weight of the access points when compared to the previous generation, and we really don't want to blow up here. So I want to spend a few minutes here at a very, very high level on the life cycle of a global use AP. So I'm pretty sure folks out there could have the confusion. Now you're saying there's only one access point, but how do I make them connect to a Catalyst mode or to a Meraki mode? So you have received your access point. So, but how do you make it connect to a WILC or the Meraki right out of box? So for some technology clarification, day zero is what we refer to as the very, very first boot, or if the AP is fully factory reset. So when you boot the AP for a very first time, it has to make a decision whether to join a Cisco 9800 wireless LAN controller or the Meraki dashboard. If the intention is to onboard to the Meraki dashboard, obviously you will ensure there is an internet connectivity present on the AP subnet, and also you have claimed these APs in the Meraki dashboard. So if the access point finds a way to reach the Meraki dashboard, and if it's claimed in the Meraki dashboard, it's going to go join the Meraki mode. If the intention is to reach a WLC, then you configure the DSCP and the DNS options that what we properly use there, like the option 43 and so on, to redirect the access point to the wireless LAN controller. After reaching the wireless controller or Meraki dashboard, it will download the respective firmware image and will continue to work in that mode for subsequent resets or reloads. When connected in the respective mode, if the user decides to migrate on day N, if he has a change in mind, if he wants to move from an on-prem to cloud deployment mode, they can do so through a very simple workflow in the 9800 UI. Or if the customer wants to move from Meraki to an on-prem based deployment, he can do so with a very simple user workflow in the Meraki dashboard. If you recollect, in the Wi-Fi 6E APs, a conversion from Catalyst to Meraki was done through a workflow in the 9800 controller. But for conversion from Meraki to Catalyst, you have to call the TAC and they will initiate the migration. And this operation is not needed anymore with the Wi-Fi 7 access points. And these knobs are available for the customers, and they can see them in the Meraki dashboard.
So let me make sure I understand this real quick here. Sorry to preempt you here. I see you're going to day 3 here, but just I think this is great because my understanding is we've taken the onus or the work off of the customers. If I'm a Meraki customer and I'm used to connecting to dashboard, it looks like really, and also if I'm an on-prem customer, used to putting my option 43 DHCP or whatever, it looks like that is pretty much the same. So I'm not having to do something new here or different or extra steps, right?
There is some extra steps that we have introduced because when the AP comes out of box, it has to make up its mind where it has to go.
Sure.
So so first it's going to look for a few minutes for the to see if it has an internet connectivity, if it can reach the Meraki dashboard.
Sure.
So after a few minutes, and is assuming it's not able to find internet connectivity or it's not claimed to the Meraki dashboard, but at the same time it has this DHCP options, then it's pretty sure that it has to reach to a wireless LAN controller, and it's going to go redirect itself to the wireless LAN controller. But as a user, if you're pretty sure you want to break the process, you don't want to waste those few minutes looking for the internet, then we have introduced some new DHCP options, and the details are all present in the deployment guide out there. So that there are some change in the way you configure the DHCP options. It's pretty much the syntax and everything is same, but it's just a new option that we have introduced.
Yeah.
And if the access points gets to learn this new DHCP option, then it's pretty sure that it has to go to a WLAN controller, and it will even stop looking for internet connectivity and redirect itself to a wireless LAN controller. Okay. There are some changes brought in, but pretty much we support all the DHCP options and the DNS options that is available out there. But it's just that for a few minutes, the AP has to make up its mind.
Sure. Yeah. I mean, it seems pretty straightforward still. I mean, it seems pretty easy.
Exactly.
Yep.
And we have put in a lot of effort. A lot of discussions have happened how to really make it very, very seamless in terms of and all the experience is very, very smooth for the customers.
Yeah, that's great.
So I want to take again 1 more minute to zoom in on the country code. Meraki, it's very simple. It joins the Meraki dashboard. You claim in a particular network. This network is assigned to a country code, and it's also based on the geolocation IP. And that's the way the AP is going to operate in the respective region or the country. But what about the controllers? In the controller, previously we used to have these different SKUs. Each country had its own SKU, or certain regions are based on a specific SKU. Now that we have only one single SKU, how are you going to determine the country code? And it's not hard-coded in the access point anymore. So through multiple methods, so these access points, at least the high-end access points, have an integrated GPS and GNSS. So the access points will obtain its geolocation and then present its country to the controller. And that's the way it's going to determine its country. That's option number 1. The second option is what we call as the proximity. If the access point, if the Wi-Fi 7 access point is present in a controller where you have a legacy AP, or it could be one of those Wi-Fi 7 AP, which has obtained its country through the GPS or GNSS, then it'll learn its country through those NDP messages that we use in the RRM. So that's the second way of learning its country code, which we call as the proximity method of learning the country code. And the third one is through migration. The customers can get all these APs to a Meraki dashboard. And in the Meraki dashboard, of course, you claim then a particular network, and you can initiate the migration from the Meraki to a Catalyst controller. So when you initiate the migration, the country code also gets carried over. So that's a very, very, if you think about it, it may look complex, but it's very, very simple. You have this access points, you have an internet connectivity, you claim them in the Meraki dashboard, and then it's a very simple workflow. You can select all these access points in a single shot and then migrate them to the Catalyst controller. It's all going to convert to a Catalyst mode. And then the last one is for air-gapped customers. It's a greenfield deployment. The APs can't acquire a GPS signal, no internet connectivity for the APs. but at the same time, the access points have to get the country code. How do they get it? Through a manual way, wherein the users can claim the access points in the Meraki dashboard based on their order ID. The APIs need not join the Meraki dashboard. It's just that you were claiming the APIs based on the order ID and then, assign them to a network. And you download a file, called regulatory activation file. This file gets installed on the controller. So when these APIs, after they have discovered the controllers, and then when they come in a kind of what you call as a universal mode. They don't have the country code. So when this regulatory activation file is present there, the WLC is going to push the regulatory activation, the country code to those individual access points through which it can learn its country code. Of course, country code determination is just done only once, unless the admin wants to triggers the country reset. You can just only clear the country configuration alone. Let's say you have an access point that is operating in a US and you want to carry them over to the Canada. All you got to do is just only clear the country config alone. So when you go connect to a wireless LAN controller, so it's just going to come in the universal mode, and then it can learn its country code with through any of those methods, like either through GPS or proximity or through regulatory activation file. So any of those methods that are available out there. The last topic on my agenda is the migration and deployment considerations. So for a successful migration or deployment, one of the key important parameters is the client support. The client, there should be a very rich set of clients that is available out there. So, and the Wi-Fi 7 clients that is available out there is picking up momentum. We have a rich set of clients. We are not there fully yet, but every month that we are looking at, the client support is really picking up momentum. We do have support in Windows now. Wi-Fi 7 is supported in Windows 11, 24H2. It is not supported in Windows 10. Mac, there is no support as of now. iPhone 16 and 16 Pro does have support for Wi-Fi 7. Android support is available from Android 13 or greater. I've been watching this, the Wi-Fi 7 certified client list every month. And I can see the number of clients that is getting added to this list growing up. And it's just a matter of few more months before we have a very rich set of clients that is available out there.
Yeah, I was just thinking here for customers maybe thinking in their head, I don't really have many Wi-Fi 7 clients here on my network yet or whatever. And to your point, next week, there's going to be a lot of Wi-Fi 7 clients under the Christmas tree or, wrapped up for people as gifts for the holiday season. So come New Year, there's going to be a lot more of these clients out there on our networks.
When you get those Wi-Fi 7 clients, make sure your SSID is configured for the WPA3 security type. Without which, if you're going to go look at your client details, it's just still going to operate as a single link client, and you're not going to see those multi-link functionality.
Yeah, good point.
So that kind of leads into the next topic. What are the recommendation tips and tricks? We just talked about the security. Security is an important consideration that you need to be aware of, and it's absolutely mandatory if you want to get those 11BE rates and MLO. And the second important consideration is the power consideration. This is one of the most frequently asked questions in all the WebEx spaces, what we have from the field. Whenever I talk to customers on the Cisco field specialists on the power recommendations, for these high-end access points, you need 802.3 BT. To be precise, it's the type 3 class 6. Up to 60 watts to operate this access point to get the full operation of the access point. You can, of course, use a 802.3 AT with up to 30 watts, but the AP is going to operate in a kind of degraded mode with less number of radio chains and special streams, and also the Ethernet speed also drops down. But if you want the full operation, you need to have the 802.3 BT or Cisco UPOE. Thirdly, we strongly recommend multi-gigabit switching. It's very easier to say, but I completely understand it's just not easy to replace all those switches. But if you look at these access points, the effective throughput of these access points is way beyond like this 5 gigabits. It's just crossed the 5 gigabits, and we have done lots of internal tests. And that's the reason we have added the 10 gigabit Ethernet port over these high-end access point. So if you want to provide the best user experience to your end users, you have to start thinking about changing your switching infrastructure to a multi-gigabit switch. Especially with these Wi-Fi 7 access point, you need a 10 gigabit Ethernet interface. Under the cabling, we recommend Cat 6 or 6A. If it's a greenfield deployment, go with any of those latest category of cable that is available out there. So that's going to really help you in a very, very long-term, kind of deployment. And Cat 5e can, of course, do speeds up to 5 gigabits though. But we strongly recommend that we use Cat 6 or 6A minimum. The wireless coverage, it's the same recommendations with what we made for the Wi-Fi 60 days. Ensure that you get a uniform cell size, especially between the 5 gigahertz and the 6 gigahertz cells because of those MLO operation. There are now 2 links. You want to have both the links to have pretty much the same kind of signal strength that the clients and the APs want to communicate to.
That's a great slide. Those are all the common questions and concerns that come up here with these discussions. So thank you for sharing that.
And of course, we are planning to come with a lot more recommendations.
Sure.
Just a kind of summary, but definitely, if time permits, we'll come back again. I'll come back 3-4 months down the line and Unplugged. We can go deep dive on those deployment aspects alone.
That sounds great.
So I use this crossing the chasm adoption lifecycle curve to kind of indicate the readiness for a standard adoption. 6 gigahertz and Wi-Fi, of course, is really mature. And we have seen a momentum, especially in the last 1 to 1.5 years. Enterprise Wi-Fi 7, I would say, is still in early stages. The reason being, we don't have a rich set of clients that is available out there. Yes, there are clients, but still there are some holes there in the clients support that is available out there. And also, if you look from an access point of view, we don't have the full breadth of access points. All the vendors have just started shipping those access points. But I do see many customers trying to start the proof of concept in the labs, and I definitely see a momentum there. There's a lot of excitement in Wi-Fi 7, and we do see customers getting started trying out Wi-Fi 7 in the labs, and then probably trying for their certification internally. And few months down the line, we can see those access points hanging up in the ceilings. So, but one thing I can say for sure is that year 2025 is going to be extremely busy with Wi-Fi 7. So this is my last slide, and I want to conclude, and I want to recommend this book on Wi-Fi 7, which is written by my esteemed colleagues here at Cisco, Jerome, Brian, Benitan, Malcolm. So these folks represent Cisco in this IEEE committees, the Wi-Fi Alliance, and so on and so forth. And they've written this book in great detail. They go really into the details of Wi-Fi 7. And this is a great read, and definitely don't miss it. And if you read through this book, I can assure you, you will be a master in Wi-Fi 7. So with that, thank you. Thanks a lot to the Unplugged team and also the viewers. Wish you all a Merry Christmas, Happy Holidays, and a Happy New Year.
Yeah, thank you, Anand. That hopefully you get some royalties from that book. Yeah, that looks like a great book there. But all kidding aside, thank you, everyone. And like Anand had said, thank you, Anand, very much for this great episode here on Wi-Fi 7 and some of the products here from Cisco that have just been announced recently and are now shipping. So really exciting stuff. I know this was a longer episode. Thanks for hanging in there. Really appreciate that. And as a reminder, you can always subscribe to our YouTube channel at youtube.com/@getunplugged. And you'll be notified when we do go live with more great content like this. And be sure to turn it on and enable notifications. If you do want to reach out to us, you can always get a hold of us through your Cisco account team, or you can reach out to us, email directly, getunplugged@cisco.com, X, Twitter at unplugged80211, or on threads at unplugged connectivity. So happy holidays from the Unplugged team. It's been a great 2024. We're going to be coming back with a new episode on January 8th after the holidays, and looking forward to that episode. So Merry Christmas, Happy New Year, Happy Holidays. Thank you very much. And until next time, stay connected and unplugged.